So we have the last talk of the day by Miles from CUNY, who's talking about creativity.
Thank you so much for inviting. Thank you so much for staying to this last talk. I'll try to bring the mic closer so you can hear me. So a presentation about creativity could not take place, at least in my universe, without an exercise where you exercise creativity at least for a minute. So think of a math topic. Whatever math topic you've seen today, or you do certain research on this, or you teach certain math topic, so grab that topic and then look around. What object would you choose? And please don't be too selective, there are not many objects around. Grab it and now think how you would explain this math topic using that object. And since there are only few people around, I'm going to walk and ask you for your explanation. So be ready at 30 seconds, or maybe 45 seconds. If it's too difficult, feel free to switch to a slightly different math topic. Okay, 30 seconds. Who would like to share your example of math topic and some object from around? And you can. Okay, what are you explaining?
Okay.
Anybody else? Feel free to explain. I was thinking about a light and explaining, like first I wanted to do derivatives, but I thought, no, that's kind of not. But then I can do continuous functions that express the luminosity of a light, right? And explain what a non-continuous function is with a jump. Okay, that's appealing.
Yeah, I was thinking about my glasses and using calculus to determine the shortest path, because basically the diffraction of light, using the shortest path kind of argument.
If you have one eye different on the other,
there's also that. Yeah, that's right.
Two exercises, wonderful. So please hold on to your experience, because later I will explain what creativity is in my universe, and I will tap to that experience. So this is the outline of my talk. As you see, I'll be talking a lot. So there are multiple pieces of that presentation. So one thing is creativity, another thing is self-determination theory. I'll try to explain what this is and how I got into it. And another thing is compassion. So multiple aspects come in one place. So self-determination theory, the Eastern Sectional Meeting, I gave the first presentation about it, and I wanted to encourage autonomy. Autonomy is one of those aspects, and during that presentation I justified why autonomy is supported by creativity. And the funny story behind it, after that presentation I thought I should read more about self-determination theory, and I was digging into many libraries, and honestly they were displaying so many publications, books, but somehow none of them was available. And I kept clicking on different links in different books, electronic resources, physical books, and nothing was available. So finally I went to a librarian and I said, this book, I cannot find anything about this self-determination theory, mainly because they are using it for companies to create a supportive environment. So everybody wants to read it. So I was actually rewarded a research library card from New York Public Library, and I can go to Columbia University, to NYU and other. I have lots of privileges as a researcher should have. I encourage you to dig into libraries. So let me start with my college and my students. So it's a large urban community college, which is part of CUNY system. It's a very wild very strange being. When I come to my class, I might see the very wide range of students, and all those numbers are changing. Usually I have half of my students are Hispanic and about half are Asian. There might be sometimes white students, sometimes black students, sometimes Native American students. So part-time students are increasing, it's almost half. More than half live below poverty line, it's a big city. We have at least 10% of international students, and that number is increasing. This may be unusual for a community college. Over 62% hold PhD, and those are researchers, serious researchers. They live in a big city, they simply did not find other jobs. It's an incredibly competitive job market. Now, the students are, as you can imagine, community college, it's like a airport, like international airport, right? People come and go, you never know, next semester, you just get completely different students. Some of our students are not well prepared, but some students are incredibly well prepared and they have huge ambitions. They want to go to Columbia University, NYU, MIT, all those best universities, and I'm supposed to, at the same time, prepare those best students and address the needs of not as well prepared students. The university is ready for that. We have numerous mentored projects to help those students, the best students, grow. However, I need to know which students qualify for those funded projects, so I need to have some creative assignments in my classes. So I will be actually talking more about brief creative assignments, just like 5 minutes, and class projects or course projects, and then longer research projects. So just last semester, for the first time, I used AI as a part of guidelines, and I showed students how to use AI in a, well, I would say creative way, but you could say ethical way. Now, while working on those creative projects, I actually grew up as a researcher, as a teacher, and a mentor. And I was trained as a pure mathematician. I had no idea about pedagogy or math education, but I was working with applied math research students. So I mentioned a path. So on this, I've been there for 12 years, so I've been asking myself questions. So what does make a good mentor, a researcher, teacher? What does make a good student? How do I help my students grow? And what circumstances make a good mentor? At the same time, I was participating, I'm a Buddhist, I actually converted to Buddhism as a teenager. So for many years, I've been asking myself, so what does it mean to be compassionate? How am I compassionate as a mentor, as a researcher, as a teacher, and so on and so on. So I do read a lot of, I do read a lot of books about psychology, and I always was very interested in that and try to relate those books to my students. So I was actually reflecting on self-motivation, the necessity of self-motivation, intrinsic motivation, in comparison to extrinsic motivation. And it actually is a part of self-determination theory. So during some of the conversations with my other Buddhists, like I participate in Buddhist discussions, and I go to a monastery to meditate for 3 weeks, 8 hours of meditation. Then I talk with other meditators, and in my understanding that I developed during those conversations and meditations, compassion begins with a refined attention. Well, for example, to my students' needs, that would be compassion in a classroom. So that's where it starts, okay, where it ends. That I hope in the next slide I'll explain where it ends. So let's switch gears from compassion and go to this self-determination theory. Historically speaking, they started talking about it in the 70s. Edward Deci and Richard Ryan. So they are psychologists. In 1985, they published a book when they crystallized their theories, And here you have intrinsic motivation, extrinsic motivation. The theory kept evolving, and eventually they ended up with like multiple sub-theories. We can drop them for now. And they point out towards 3 basic psychological needs that need to be fulfilled for people to feel comfortable. One is autonomy, competence, and relatedness. Let me explain a little more. Autonomy. So people are more motivated when they have certain control over their choices and actions. But on the other side, too many choices, they are confusing. So if we give our students a choice, would you have a test on Monday or on Wednesday? They might feel they have control over something. And that already makes them feel better. It's not much of a control, but it's already something. A competence is a sense of mastery and ability to succeed. And we completely fail in that matter, especially for lower level math classes, because students feel that they are not competent. But we can address that. So the challenge that students should experience needs to be tailored to their abilities. And that's where we fail as well, giving too challenging things to students with lower abilities and too easy things to students with high abilities. I will reflect on that later. And relatedness. This seems to be the simplest thing to address. Students should feel connected to other students, or the teacher, or they could be connected to the topics. So a student who is very much interested in a topic doesn't necessarily need to be connected to a community, especially if that student is an introvert. So that's another part of the vision. Introverts and extroverts connect differently and relate differently. So let me quickly explain what creativity is. By association means that we have 2 frames of references, and creativity is simply going between those 2 frames. So our minds, in a natural way, have already 2 frames. One is weak connections, strong connections. However, the exercise that I gave you at the beginning was completely different. It was more a mathematical concept versus an object. And so it's not exactly that. You can say that applied mathematics has 2 references, 2 frames of reference. Applications, that real world, and then mathematical world. It's much easier to make a shift and walk between those 2 frames than the conscious and subconscious. So, in neuroscience and cognitive psychology, strong connections are well established, frequently used neural pathways. Whatever you are certain about, whatever you believe in strongly, repeat many times, that's the strong connection. Weak connection is, something you heard of, maybe you're not certain, it's just less reinforced, newly formed, something casual. That's the weak brain connection. Now, let me say what kind of activities I give to students and how creativity is realized there. So I started with research projects. Those are the long projects, and I grew from being a mentor, I grew into those course projects. Then I thought, students should be exposed to creativity before they are given 6 weeks, before they invest their time in this long. So first, we do short creative assignments. To give an example, we introduce whatever definition. I ask students to provide examples of what they think is that object, or maybe they actually mistaken. In Calculus 3, we talk about typical regions. So I used to bring a list of regions that are typical, type 1, type 2, and just bring a list of regions that are not typical and have a beautifully organized lecture according to that. Now I do it differently. I ask students what are their examples, and then I have to do a lot of creativity right on the spot and organize those examples in some reasonable alignment. But students feel more engaged. Right? They bring their own examples, they have to dig into their subconscious, they think their voice is heard, they relate to each other, they relate to me, So they feel more autonomy, and they feel more relatedness, and they hear their voice is heard. So the first few brief assignments, students are confused, but as soon as they get used to it, they actually enjoy it very much, and they have fun, and they play with that. Now, course projects, I usually assign them for 6 weeks, provide the guidelines. Students find their own subject related to a class topic and their own interest major. Many students that I teach are engineering majors or computer science majors. So to give an example, a student who was actually a high school student, he really liked roller coasters, and he was taking differential equations class in a community college, right? So he did a project about how the roller coasters are designed, and everybody loved it. So he received a lot of appreciation, right? A lot of attention, and he felt very accomplished. Of course, the other aspects were he worked in a group. Actually, those older students, 24 and up, they grouped around him because he had an idea. Research projects, so at least summer 6-week projects, sometimes year-long, sometimes semester-long. I published actually a book about 30 or 50 topics, projects that we developed over last 10 years. Geometrical solar panels, you can actually bend the panel, rotate it, and we built a model for that. And my students, listen to students. It was an idea of my students. They wanted to figure out how to make the city green, right? And how to put the solar panels so they are efficiently placed. How is autonomy supported? So I gave a talk about it, so I'll just go quickly over this. During the stages of creativity, first we use those strong connections, but then during the next stage, we actually tap towards our weak connections, towards the subconscious. And then subconscious reveals its information to the surface, to the consciousness, and we just keep going back and forth like this. We have a lot of options. We have to make choices for both subconscious exercises, its weaknesses, and the consciousness exercises as well. So in a classroom, we actually creative assignments exercise competence. So we try to give partial credit generously, right? Whatever assignment we do, but in fact, what should I to say? So some students are encouraged by this partial credit they get, but some students are very discouraged that the partial credit they lost. Mm-hmm. So we are not actually addressing everybody's needs, but if we introduce creative assignments and we introduce new competence, creativity, and say, well, you didn't know that you're creative in mathematics, but maybe you are. So this way we can redefine the rules of the game and then convince the students that they could be creative if they simply put their time, effort, attention, or maybe just some other things that they didn't even know they exist. Okay, so in a classroom, relatedness. Students can collaborate together on working on creative assignments. They can collaborate with a mentor, with other mentees. Moreover, they can relate other subjects to mathematics. I have 10 minutes. All right. Now, this is the best part. So as I mentioned before, I started actually with the research and being a mentor. So how does working on research and doing creative research, how does it affect students? So in my research project, students actually choose their own topic. And they work on they take the ownership of the project. Even if they refine or rephrase the previous subjects, they always find the topic that is interesting to them. So talking about the solar panels, I started with solar panels in New York City, but then we moved the solar panels to the satellites. There was another group of students. Another group of students, we moved it to Mars. Another group of students, we moved it to the moon, which is actually much more difficult because the moon does not have fixed axis of rotation, right? So its axis of rotation moves. It was quite challenging for me because I'm the one who creates those models, and students do the calculations. So how does it increase students' competence? So students feel very much elevated by working on research, right, with a mentor, or when they give presentation, they write a paper, we publish those papers. This is amazing, a true research experience. Now, how do they relate? Well, they actually stay in touch with their mentor, but they interact with the group, other mentees, with the audience. And this is amazing experience for them. Now, and then I kept thinking about it, like, wait, but working on research with students and introducing those creative projects in the classroom, it actually affected me. So first of all, I can invent my own project and my own topic. And I don't have to obey to the curriculum. And moreover, I can test that project in multiple classes. I can speak with students, get their feedback, and do what students like, what I like. So I can actually shape my own experience, my own career independently from whatever the administration tells me to do. Amazingly, this increased my competence. So having those creative topics, every time we had a poster session, other professors would come to me and say, how do you invent those creative projects? I'm like, well, I don't know, I just talk with students. So actually those questions from other faculty made me write a whole book. It's like 200 pages where I explain like how I was thinking about those projects that became so creative. So it impacted my competence. I became a better researcher and a better teacher because I introduced those creative projects in my classes. So of course my mentoring experience pushed me on my trajectory as a teacher. Now how about relatedness? Well, in our classes, we're not always feeling that students are grateful, but my mentees are incredibly grateful because thanks to those projects and those recommendation letters, right? They went to MIT, they went to Columbia University. They actually, my students won scholarships to go to those universities. So it entirely changed their entire career path. So at the same time, I collaborate with my colleagues when preparing projects for students. I can relate to them more and over and over. And I create collaboration while working on writing papers about those projects. And many projects are actually collaborative projects with other faculty from psychology, from engineering, different specialties, and from computer science. So actually I became an applied mathematics researcher. So what are my conclusions? At the beginning I asked questions, right? So first of all, creativity is a possible way, not the only one, of addressing all three components of what was this theory? Development theory, no,
Determination.
Determination, sorry, keep forgetting things. So I had a question about compassion. So what does it mean to be compassionate researcher, compassionate mentor? So as you saw, this work impacted my students and impacted me. It's a mutual exchange. So we have two frames of reference, the teacher and the student. So it's the exchange of compassion between us. So this is the exchange that creates good students, good teachers, good researchers, good mentors, good people, good environment. So there's one mistake that I realize that many of us are making. Like we cannot be just selectively compassionate only to students. Okay? Include yourself. So thank you so much for your attention. I hope I opened a lot of questions. I still have 4 minutes. Wonderful. So I do have references. So those are references about the self-determination theory. I included 2 other references about creativity, The Art of Thought, as my favorite book, over 100 years old, and Mihaly Csikszentmihalyi about creative flow. And I do have some advertisements, a quick photo. So things like this are deeply analyzed by philosophy of mathematics education. In 2023, I had this pure joy to co-edit a book, Ongoing Advancements in Philosophy of Mathematics. If you think that the title is spooky, I invented it myself, but everybody accepted it and the publisher didn't complain, and now we have a title. And then I committed this book on creativity in STEM fields, A View from an Eclectic Mind, 2024. And in 2026, we are actually preparing another book by Springer, exploring the richness of being human through mathematics, education, philosophy. I didn't make the title, that was Bronisław Czarnocha. We are going to discuss compassionate mathematics. And the entire first part of the book, and I'm actually the editor of that first part of the book, is about beauty, compassion, creativity. All right, thank you so much.